now we're going to do question 1. In 1.1 we are asked to solve for x. So 1.1.1, we're going to solve for x for this problem here. So we have x squared plus 5x minus 6 being equals to 0. So the first step we're going to do is factorize this problem here, equate to 0. The factors of x squared is x and x. Factors of 6 such that they give us the middle term, it's going to be 6 and 1, right? And 6 will take the sign of the middle term, so it's going to be plus, and this would be in negative. So it's going to be x minus 1 being equals to 0, or x plus 6 being equals to 0. Then x equals to 1, or x being equals to minus 6. So these are our solutions of x. We're going to do 1.1.2, where we are given this problem here and we are asked to write our answers to 2 decimal places rather. So we're having 4x squared plus 3x minus 5 being equals to 0, and the quadratic formula is equals to minus b plus or minus root of b squared minus 4ac divided by 2a, and our value of a is equals to 4, our value of b being equals to 3, value of c is equals to minus 5. So we're going to substitute these values into our quadratic formula. So it's going to be minus into 3 plus or minus the root of 3 squared minus 4, our a value being 4, our c value being minus 5. And then we divide by 2 into our a value being 4. So the solutions of x that you're supposed to get for this problem is minus 1.55, or x is equals to 0.80. So these are your solutions of x in 2 decimal places. 1.1.3, where we also solve for x for this inequality problem. So the first step, we're going to write our equation 4x squared minus 1 being less than 0, right? And we're going to factorize this problem here. So we're going to have 2x and 2x, right? Difference of 2 squared, so it's going to be plus 1 and minus 1 here. Then our critical values is 2x plus 1 equals to 0, or 2x minus 1 equals to 0. So we're going to have 2x being equals to minus 1, or 2x being equals to 1. So we divide by 2 both sides. We have x being equals to minus 1 over 2, or x being equals to 1 over 2. So these are our critical values, right? And remember that the solution that we want is when our y value is negative, right? Because the inequality is less than 0. So we want to go to our number line, right, and present our critical values. So we have a critical value of minus 1 over 2 and a critical value of 1 over 2, right? So these are our critical values. So we're going to test values before and after our critical value. So a number before minus half it can be minus 1. A number between minus half and half, it can be 1 over 4. A number after half, it can be 1 also. So you're just going to test these values here and identify the signs of y, right? Because you're going to be testing them into the equation of 4x squared minus 1, right? So where you see x, you would put x being equals to minus 1, and then find its solution, right? And then you also test this one here where x is equals to 1 over 4, and find the solution for that. So find the sign, and then when x is equals to 1, you find the solution, right? So what I found was when I substituted x being equals to minus 1, I got a positive solution of y, right? So meaning that here it's going to be positive solution of y. So whatever x value that is less than 1 over 2 minus 1 over 2 is going to give you a positive solution of y. And then when I substituted for x being equals to 1 over 4, I got a negative solution of y, right? So and then after half, which is this critical value, I got a positive solution of y. So we're only interested in the negative solution of y, which is this one here. So you will conclude using your critical values. You will say x must lie between minus 1 over 2 and 1 over 2. So this is your solution for this problem here. Now we're going to do 1.1.4. So we're having the root and another root inside where it's 32 plus x, and then there's brackets. We have another root here which has a root of 32 minus x, and then there's a close bracket being equals to x, right? So to solve this problem, we can use a difference of two squares, right? You know, when x squared minus 1 is the same as x, let me remove this, same as x plus 1, x minus 1, right? So you're just going to do the same thing inside here, and we'll use one bracket. So it's just going to be this big bracket here and a difference of two squares inside. So it's just going to be the root of 32 plus x and the root of 32 minus x, and then equals to x, right? So we're just going to square both sides, so we can square this side here and square this side here, and then we'll remain with the root of 32 plus x, the root of 32 minus x being equals to x squared, right? So since I said this is the difference of two squares, can simply multiply this square root and this square root here. You're gonna have 32 and then minus, we don't have to multiply this root of 32 and this minus x, right? Because the difference of two squares, you can simply multiply this x and this x here. We'll have minus x squared like this, right? So it's going to be equals to x squared, and then we transpose this to the other side. We have 32 being equals to x squared plus x squared. So we have 32 equals to 2x squared, right? And then we divide by 2 both sides. We have x squared is equals to 16, and then the square roots both sides, we have x being equals to plus or minus 4, right? And then our final solution would be equals to 4. So that is the solution for this problem here. Now we're going to do 1.2, where we are asked to solve for x and y for these two equations here. So we're having y plus x being equals to 12, and we can say this is our equation 1, and xy is equals to 14 minus 3x being equation 2, right? So let's choose one equation so that we can use as equation 3. Let's choose this one because it looks simpler. We can simply say y is equals to 12 minus x, and it's equation 3. So we're going to substitute equation 3 into equation 2, right? So whenever we see y, we're just going to put 12 minus x. So we're having x into our y, right? So it's just going to write 12 minus x being equals to 14 minus 3x, right? So this x will multiply everything inside, so it's going to be 12x minus x squared is equals to 14 minus 3x, right? And then we're going to collect like terms, so it's going to be minus x squared plus 12x plus 3x minus 14 equals to 0. And then minus x squared plus 15x minus 14 equals to 0. Divide by negative both sides. And then we will have x squared minus 15x plus 14 being equals to 0. Right? So we're going to factorize this problem here. So it's going to be x, and then factors of 14 such that they give us the middle term. It's 14 and 1 have to be negative both sides, and then we equate to 0. So x minus 1 is equals to 0, or x minus 14 equals to 0. X is equals to 1, or x is equals to 14. So these are your solutions of x. Now let's find solutions of y. Remember that y is our third equation, which is equals to 12 minus x, right? So when x is equals to 1, our y value is equals to 12 minus 1, which is equals to 11, right? So when x is equals to 14, our y is equals to 12 minus 14, which is equals to minus 2. So these are our solutions of x and y. Now we're going to do 1.3, where we are told to consider the product of 1 times 2 times 3 times 4 all the way up to times 30. And we are asked to determine the largest value of k such that the factor is 3 to the power of k, right? So what we know is this, that we are having a product of 1 times 2 times 3 times 4 all the way up to times 30, right? And the factor that you are given is 3 to the power of k, right? So this is a hint. It tells us that because we want the value of k, which is on top, right, it's an exponent. It means now that this 3 to the power of k must be equals to the same base of 3, such that we will just drop the exponents, right? So let's find the multiples of 3 that exist in this product here, right? So we're having 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30, right? So I'm just going to write them properly. So it's going to be 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. So these are our multiples of 3, right? And then let's write these multiples in terms of base 3, because our factor is 3 to the power of k. So this 3, to write it in exponent form, we can simply say just 3 to the power of 1. And this one here, we know it's made of 3 times 2, right? So just going to write the 3 that exists there. And then this one is made up of 3 to the power of 2. And then here we can say 4 times 3, right? So which is actually 3. And then 15, we know it's 5 times 3. So you can just put 3 here, so all to the power of 1. And then here we can say 3 to the power of 2 multiplied by 2, because 3 to the power of 2 is 9. 9 times 2 is 18, so it's going to be 3 to the power of 2. And then here it's going to be 3, because 7 times 3 is 21. And then here we have 24, so it's going to be 3, because 8 times 3 is 24. And then this one here of 27 is 3 to the power of 3. This one here is 3 to the power of 1, right? So we're having all these bases here, but we need to add all the exponents of these bases because we already have the factor. our factor is 3 to the power of k, right? And we just need to equate it to 3. We have exponent of 1 here, exponent of 1, exponent of 2, exponent of 1, exponent of 1, and exponent of 2, exponent of 1, exponent of 1, exponent of 3, and exponent of 1. So we'll simply add the exponents. So it's going to be 1 plus 1 plus 2 plus 1 plus 1 plus 2 plus 1 plus 1 plus 3 plus 1, right? So by adding the exponents, we have 3 to the power of k being equals to 3 to the power of 14. So this concludes now that the largest or maximum value of k is equals to 14 for this problem here. We're going to do question 2, and we're given this quadratic sequence of 321, 290, 261, and 234. So the sequence continues. In 2.1.1, we are asked to write down the next two terms of the sequence. So what we're going to do is you have 321, 290, 261, 234. So to write down the next two terms, we're just going to find the first difference of the sequence, which is minus 31, minus 29, minus 27, and we find the second difference being 2, right? So we know just the first difference is 290 minus 321, just like that, 261 minus 290 to get the first difference, and then the second difference, we just subtract these two here. So it's saying minus 229 minus 31 to get the second difference, right? So to find the next terms, the next two terms, so because the second difference is 2, it means now this sequence is increasing. Remember, it's negative 31, it's smaller, and this negative 27 is larger. So this sequence is increasing by 2, right? By a constant difference of 2. So meaning that here it's going to be minus 25, and then here it's going to be minus 23, right? So as it decreases, what we're going to do is we're going to say this 234, we're going to add it with this minus 25, and then we get our following sequence, which will be 209, and then we do the same thing. We say this 209 plus this minus 23, we're going to get 186. So these are our next two terms of the sequence. Now 2.1.2, we are asked to find the general term of the sequence in the form of Tn is equals to an squared plus bn plus c. So to find the general term, we are having our sequence, or our quadratic sequence rather, being 321, 290, 261, 234, 209, and 186, right? So we're going to first find the first difference of the sequence, right? So the first difference, we have minus 31, minus 29, minus 27, minus 25, and minus 23, right? So, and then the second difference of the sequence is going to be 2, right? So it's 2, 2, 2. So to find the value of a, so we're going to say 2a is equals to 2, which is the the second difference rather, this second difference. And let me just label this as the first difference. So to find the value of a, we're going to divide by 2 both sides. So our a value is equals to 1, right? And then our going to use the first difference, so it's going to be say 3a, and then we're going to use our first difference, so we're going to say 3a plus b is equals to our first term of our first difference, which is minus 31, and we know that a is equals to 1, so a into 1 plus b is equals to minus 31, right? So you're going to transpose this to the other side and find your value of b, so which you'll find b being equals to minus 34, right? And then to find the value of c, we're going to say, so let me remove this, we're going to say a plus b plus c is equals to the first term of your sequence, your quadratic sequence, which is this one, 3, 2, 1, and our value of a is equals to 1, our value of b is minus 34, plus c is equals to 3, 2, 1. You're going to add everything up, and your c value is supposed to be 354, right? So you have your value of a, b, and c now, so you'll be able to identify the formula. So Tn is equals to an squared plus bn plus c, right? And our value of a we found to be 1, so it's going to be n squared. And our value of b, it's minus 34, so it's minus 34n. And our value of c is equals to plus 354. So this is our general term of the sequence. 2.1.3, which terms of the sequence will have a value of 74? So we're going to use our Tn, so Tn is equals to n squared minus 34n plus 354, right? So which term is equal to 74? So it's 74, so it's going to be 74 equals to n squared minus 34n plus 354. So we're going to transpose the 74 to the other side. We have n squared minus 34n plus 354 minus 74 equals to 0. So we have n squared minus 34n plus 280 being equals to 0. So to find the value of n, we can use our quadratic formula, which is n being equals to minus b plus or minus the root of b squared minus 4ac divided by 2a. And we're going to substitute into our quadratic formula. So n is equals to minus our b value, it's minus 34, plus or minus the root of minus 34 squared minus 4, our a value is 1, our c is 280, and then we divide by 2 into 1. So our n is supposed to be 20, or n is supposed to be 14. So remember, we are asked to find the value of n such that the general term was equals to 74. So these two n values are applicable since we were asked to find the number of term, open bracket s, which is terms. So yes, this is the final answer for this question here. 2.1.4, which term in the sequence has the least value? So we want to identify the term. So I'll first draw a diagram. So this is our Cartesian plane. Normally in a Cartesian plane, the x-axis has the x values, right? In this case, it's going to be n, right? Because our formula Tn is equals to an squared plus bn plus c, right? So why am I doing this? You must take note that the quadratic number pattern is actually a parabola, right? So n squared minus 34n plus 354 is the formula that we got, right? And you can see that this is actually the standard form of a quadratic number, a quadratic graph, right? Or should we say a parabola, right? So for us to be able to represent this equation here, we know, as I wrote here, it's n, meaning that these n values here are representing the x-axis, and the Tn represents the y-axis, right? So it's going to be Tn there, and then let's say I draw a parabola that looks like this, right? and we want to identify the n value that gives us the least value. So when you talk about the least value, we're going to look at Tn in this case, but normally you'll be looking at your y values. But since our y-axis is Tn, so we want to find which point does this parabola have the least value of Tn. It's at the turning point, right? At the turning point, you have the least or the smallest value of your y, because you're used to the y-axis, right? Your y values, which in this case the Tn. So if you were to write the turning point, it's going to be n and Tn, right? So I want to find the smallest value of Tn. The smallest value of Tn happens here, but for us to identify the term when the smallest value of Tn is at the turning point, we need to use this formula of x being equals to minus b over 2a, right? Because we are looking for the term and not necessarily the least value. If we're looking for the least value, we're going to use this x being equals to minus b over 2a and substitute it in the Tn formula to find the least value, the specific Tn value, which is the smallest value of this parabola, right? But we are looking for the number of terms, the n term, this n value here, the number of the term which gives us the smallest value. Sometimes they can say the minimum value, right? It gives us the minimum value of the sequence, right? In this case, we are looking at the equation here. So to find the minimum, or the term rather, which gives us the minimum value, we're going to say, so it's going to be n is equals to minus b over 2a, which is equals to, so our b is equals to minus 34. So it's minus 34, which I took from the equation, and our a value is equals to 1. So you just want to substitute that minus into minus 34 divided by 2 into 1, right? So you'll find that your n value is equals to 17. So this is the n value which will give you Tn, which is the smallest, which will give you the smallest Tn value of the function. Going to 2.2, we are given this geometric series here of 5 over 8 plus 5 over 16 plus 5 over 32 plus going up until it gives us a sum of k. So this is the sum, Sn, which is equals to k, right? So 2.2.1 says that determine the value of k if the series has 21 terms. So you know that the sum is equals to k, right? So we're just going to use the geometric series equation to find the specific value of k. So we know very well that the sequence, let me just write the sequence. The sequence is this one here, right? 5 over 8, 5 over 16, and 5 over 32. So it's going to be 5 over 8 plus 5 over 16 plus 5 over 32 being equals to k, right? And we're going to find our value of r. So if this is, let me do this. This is term number 1, term number 2, and term number 3. So our value of r, because this is a geometric series, so it's going to be t2 over t1 equals to t3 over t2, right? So term number 2 is equals to 5 over 16. Then we divide by term number 1, which is 5 over 8, equals to term number 3, which is 5 over 32. Then we divide by 5 over 16, right? So your r value that you need to get is 1 over 2, right? So now we're having our r value and we're having our a value being equals to 5 over 8. We can simply find the sum of the sequence and equate it to this k, because k is actually Sn. So the geometric series equation of the sum is Sn being equals to a into 1 minus r to the power n divided by 1 minus r, right? And Sn is equals to k being equals to a, which is our first term is this one here, which is 5 over 8. So we're just going to write 5 over 8 into 1 minus our r, it's 1 over 2 to the power of 21 terms, right? And then divide by 1 minus into 1 over 2. So what you're gonna do, because we are looking for the value of k, so you can simply punch this whole expression here in your calculator if possible, or you can just simplify it further. But I did punch everything out in my calculator, and I got the answer of 1.25. So this is my value of k. 2.2.2 says that determine the largest value of n if we're having Tn being greater than 5 over 8, 1, 9, 2, right? So what we have here is this, we want to identify the largest value of n, right? When Tn is greater than 5 over 8, 1, 9, 2, right? So we're still going to use the geometric series, which we know our a value being 5 over 8 and our r value being 1 over 2, right? So Tn of a geometric series is Tn is equals to a r to the power n minus 1. In this case, to find Tn, our a value is going to be 5 over 8, and then r it's 1 over 2 to the power of n minus 1, right? So we are looking for the n. So we can simply substitute this Tn here, which is this one, into here, right? Just here at Tn. So we're just going to do that. So meaning we're just going to say, since Tn is greater than 5 over 8, 1, 9, 2. So we're just going to write this here, which would be 5 over 8 into 1 over 2 to the power of n minus 1 greater than 5 over 8, 1, 9, 2. Right? So what we're going to do is we can remove this 5 over 8 by dividing it out. So we'll remain with 1 over 2 to the power of n minus 1 greater than, so we're going to have 5 over 8, 1, 9, 2 divided by 5 over 8, right? And you will get 1 over 2 to the power of n minus 1 being greater than 1 over 1024, right? And then because we're looking for the value of n, so we can make the base the same. So it's 1 over 2 to the power of n minus 1 greater than 1 over 2 to the power of 10, right? So the bases are the same. It's 1 over 2, 1 over 2. So you drop the exponent. So it's n minus 1 being greater than 10. And then you transpose the negative 1 to the other side. We have n being greater than 10 plus 1. So it's n greater than 11. So to find the conclusion of the value of n here, you need to substitute your values of n. So what you're going to do is this, because you'll be having this part here, I'm just going to shade this part, you'll be having this part here. And we are told that Tn must be greater than 5 over 8192, right? So you want to substitute your value of n here. Now that we found n being greater than 11, right? We found n greater than 11. So you're going to substitute n being equals to 12 and see if you're going to get a value that is greater than your 5 over 8192. But if you don't, then which means if it becomes smaller, then which means you need to use an n value that is less than 11, right? Which is what I found when I was solving this problem here. Found that as you go up, if you say you use 12, it doesn't give you Tn being greater than 5 over 8192, right? So what I did was I used a smaller value of n, right? So instead of going up to 12 or 13, just go less than 11, right? So you can test 11 and see if it's going to give you Tn of greater than this 5 over 8192, right? And the conclusion that I found when I was testing everything is that if you use n equals to 10, it definitely gives you Tn being greater than 5 over 8192. So the answer that you're going to get is definitely going to be greater than 5 over 8192. So n being equals to 11 is the final answer of this problem. Okay, so now we're having this question here, question 3. In 3.1, we are asked without the use of calculator to find the value of this two sums here, right? The difference of these two sums. So for us to do this, I want us to note something. We are having the sum 10 y is equals to 3, so it's 1 over y minus 2, right? And then minus the sum at the top is 10, y is equals to 3, and it's 1 over y minus 1, right? So for us to solve this, we can identify the sum or the entire number of terms for this portion here, right? We can just identify all of them because we are starting at y is equals to 3 and ending at 10, right? So it's not really a lot of terms, so we can just write down all of them. And the same applies with this part here. We can just write down all the terms and subtract with these ones here, right? So let's start that process. So what you're going to do is you're just going to say let's first start by solving this one here, right? And just identify all the terms that it has. So we have the sum of 10 y is equals to 3, 1 over y minus 2, right? So when y is equals to 3, we have 1 over 3 minus 2, right, which is equals to 1 over 1. When y is equals to 4, we have 1 over 4 minus 2, which is equals to 1 over 2. When y is equals to 5, we have 1 over 5 minus 2, which is equals to 1 over 3. So if you can check, even if we increase y is equals to 6, so it's 1 over 1, it's 1 over 1, 1 over 2, 1 over 3. So basically it's just going to go up until, let's just write everything so that you can see. So it's 1 over 6 minus 2, which is just going to be 1 over 4, right? Y is equals to 7, it's going to be 1 over 7 minus 2, which is 1 over 5. And y is equals to 8, so it's going to be 1 over 8 minus 2, which is 1 over 6. Y is equals to 9, 1 over 9 minus 2 is equals to 1 over 7. And y is equals to 10, which is 1 over 10 minus 2, which is 1 over 8. So we are done. We are done writing all the terms for this first sum, right? This first sum here. So let's just write down all the terms. So I'm just gonna put them inside a bracket, all these terms here. So we have 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5 plus 1 over 6 plus 1 over 7 plus 1 over 8 plus 1 over 9, right? So these are the terms for the first sum. Let's now find the terms. Oh, sorry, it's 1 over 8. It ends at 1 over 8. Let me correct myself here. So it's 1 over 8, right? This is the last one. Cool. So these are the sum for these are the terms rather for the first sum. So now let's find the terms for the second sum. So the second sum, it also has 10, so y starts at 3 and it's 1 over y minus 1, right? So when y is equals to 3, we have 1 over 3 minus 1 is equals to 1 over 2. When y is equals to 4, we have 1 over 4 minus 1 is equals to 1 over 3. When y is equals to 5, we have 1 over 5 minus 1 is equals to 1 over 4. Y is equals to 6, we have 1 over 6 minus 1 is equals to 1 over 5. Y is equals to 7, we have 1 over 7 minus 1 is equals to 1 over 6. Y is equals to 8, we have 1 over 8 minus 1 is equals to 1 over 7. Y is equals to 9 is equals to 1 over 9 minus 1 equals to 1 over 8. Y is equals to 10, we have 1 over 10 minus 1 is equals to 1 over 9. So to write all these, we have 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5 plus 1 over 6 plus 1 over 7 plus 1 over 8 plus 1 over 9. So these are the terms for this sum here. Remember, the first sum that we got, we're going to subtract with this second sum. So this is what it means. Remember, we are saying the first sum of 10 y is equals to 3 and then 1 over y minus 1. We are subtracting this sum. Let me put a different color. Subtracting it with this second sum, 10 at the top, y is equals to 3, 1 over y. Okay, sorry, this is actually 2. And then this is minus 1. Right, so we are subtracting these two sums. So we already identified that all the terms from y is equals to 3 up until 10, right, for this part here and also for this one here. So let me write for these ones here. We found 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5 plus 1 over 6 plus 1 over 7 plus 1 over 8. So these are all the terms that we found. And then it subtracts these terms here for this sum here. So it's started at 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5 plus 1 over 6 plus 1 over 7 plus 1 over 8 plus 1 over 9, right? Cool. So what I need you to look at here in this problem is that because we are subtracting this and this, right? So this, where you see numbers that are common, you know very well that they are going to disappear because they are going to subtract each other. So this 1 over 2 will subtract this 1 over 2, so they go away. This 1 over 3 will subtract this 1 over 3, so they go away. 1 over 4 will subtract this 1 over 4, so they go away. And then 1 over 5 will subtract this 1 over 5, so they also go away. We have 1 over 6 subtracting 1 over 6, cancel out. 1 over 7 subtracting 1 over 7, so you also cancel out. 1 over 8 subtracting this 1 over 8, so you cancel out. So what remains? What remains is this 1 over 1, right? Subtracted by 1 over 9, right? This 1 over 9 here. So we're just going to separate these two here to find a final answer of these problems. So it's just going to be 1 over 1 minus 1 over 9, which should give you an answer of 8 over 9. So this is the solution for this problem here. And now we're going to do 3.2, right? We are given a statement that reads as follows: a steel pavilion at a sports ground comprises of a series of 12 steps. So we're having 12 steps, of which the first 3 are shown in the diagram below. So the first 3 steps are shown in the diagram below. So each step is 5 meters wide and has a rise of 1/3, right, meters, and has a breadth of 2/3 meters as shown in the diagram. So if you can see the diagram there. And then the below statement says that the open side shaded on sketch, so this is the open side that is shaded, right, on each side of the pavilion, so on each side. So this is also another side where it's shaded, right, must be covered with metal sheets. So these sides must be covered with metal sheets. Calculate the area of metal sheet needed to cover both sides. So you need to calculate the area of these sides and the other side that is on the left hand side, right? So for us to calculate that, we need to take note of the following, that we are having 12 steps. Those are the total steps, right? Because here, this would be the first step. If I were to highlight, this would be the first step, right? And this would be the second one. This would be the third one, just like that. So we're having a total of 12 steps, right? And another thing is that we are having the thread is 2/3. Thread of the steps is 2/3, and the rise is 1/3, right? So basically, the area of the step, this part here, this portion here, is 2/3, and this portion here is 1/3, right? And another thing, because the reason why we are focusing on this, remember, we want the side. So the side of the step is looking like this, So we are interested in the side of the step, not necessarily this base here, right? Because we want to identify the area of the metal sheet that is going to cover the side. So the side consists of 1/3 and 2/3, right? So let me just write it nicely. Remember the steps, as I said, we are interested in the side. So it's going to look something like this, the side of the steps, right? Where here it's 1/3 meters, here it's 2/3 meters, right? So we're interested in the side of this steps, right? So what's going to happen is this, because we're interested in the side, so we're just going to add all 12 steps. This would be your first step, right? Step number 1, and then step number 2 is step number 1 and step number 2. So this would be number 1, this would be number 1 and number 1, right, which making number 2, right? And then this one here would be number 1, and number 1. So this is the first step, this is the first step, and another step, making it 2 steps. The first step, the second step, and the third step, right? So what we're going to do is, these are actually 12, right? So we're going to say, fine, our step is to find the area of the step. Our step is composed of 2 things. This height of 1/3 multiplied by 2/3, right? So this multiplied by this, right? And we having how many steps? Because this is only for one step. This is only for one step, right? How many steps do we have? We have 12 steps, so we need to indicate all 12 steps. So we're gonna say 1 plus 2 plus 3 steps, right? Why am I saying 1 plus 2 plus 3? Because this is 1, this is 2 because it's 1, 2, this is 3 because 1, 2, and at the top is 3, right? up until you get to 12 steps. So plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11 plus 12. So these are your 12 steps. Remember, we are interested in two sides of the steps that are shaded, right? I even indicated that here. It's shaded on this side and also on that side. So we are interested in both sides. So what we're going to do is we're just going to multiply by 2 here because we're interested in both sides, right? So this is for our step, and then this is for the number of steps that we have, and this stands for the sides, right? So our area, let me write it nicely. So our area of this metal sheet, area is equals to, so just gonna find the product of the whole thing here that I just did here using your calculator, and you should get something like 34.67 meters squared. Question 4. So now below are the graphs of f of x and g of x. So in this first bullet point, we are told that f has a turning point at C and passes through the x-axis at 1 and 0, right? So it has a turning point here. This is the turning point of f, right? And passes through this intercept here, right? And then D is the y-intercept of both f and g, so this is D. The graph of f and g also intersect each other at E, so both graphs intersect each other here at point E, and at J, so they also intersect each other at this point here. So the vertical asymptote of G passes through the x-intercept of F, right? So this the intercepts, right? And then the asymptotes are passing through here. So let me just indicate, so these different color. So the asymptotes, we are told that they are passing through here, right? So this is the horizontal asymptote. Now what we have here is 4.1. We are told to write down the value of P. Let's see what they are looking for. So the value of P is basically this one here, right? So we are given, so that's basically the vertical asymptote, right? But P is not, it's just the value on its own. So this is the vertical asymptote. We are given the vertical asymptote to be equals to 1, right? We know x plus P is equals to 0, and we know that the vertical asymptote is equals to 1. So if you take this 1 to the other side, we have x v minus 1 is equals to 0. So the P value is actually minus 1. So this is the value of P, right? As I said, this is the vertical asymptote, x equals to 1. As you can see here, it goes all the way up, right? And this hyperbola here, it doesn't touch the asymptote, right? As you can see here. Fine, so now we're done finding the value of P, which is equals to minus 1. Then 4.2, we are asked to show that A is equals to 3 and B is equals to 2. So for us to show that this value of A and this value of B here, for us to do that, we need to go to our graph and because we're having f of x being equals to what? X squared. So it's x squared plus bx and then minus 3, right? So minus 3. So for us to find this b, we can use because this is f, right? F of x, this one here. If we use this point here, which is 1 and 0, it means now that here it's going to be 0 and then at x is going to be 1. So we're just going to substitute 0 here, and then here it's going to be 1 squared plus b into 1 minus 3, right? As I said, we're using this y-intercept. So it's going to be 0 is equals to 1 plus b minus 3. So it's going to be 0 is equals to b minus 2. So transpose the 2 to the other side. We have b is equals to 2. So we have proven that b is equals to 2. So now we have to prove that a is equals to 3. So for us to do that, we having our equation of g here, right, which is g of x is equals to a value over x plus p. So it's a value over x plus p. Remember we said p is equals to minus 1. P is equals to minus 1. So g of x is equals to a over x minus 1, right? And to find the value of a, we can use any available point here. What is it? If we try point D, because that's the y-intercept. So this point D here, I'm just going to indicate with this blue. This point D here, try point D, which the coordinates of point D are, we know that the y value is minus 3, right? So it's minus 3 and x is 0, so it's minus 3. So you're just going to substitute in this equation. So you're going to say my g of x is equals to a over x minus 1, and we substitute our d, which is 0 and minus 3. So it's going to be minus 3 is equals to a over 0 minus 1, which is equals to minus 3 is equals to a over minus 1, cross multiply. My a is equals to 3. So that's how we found a being equals to 3. So yeah, we're done with 4.2. Now we're going to do another question, which is 4.3. So now that we've done 4.3, we are asked to calculate the coordinates of C. So what are the coordinates of C? What is C in the graph? So let me remove some of the info so that we can see what is C. C from the graph, let me first look. We were told that F has a turning point at C. So C is actually the turning point. Here it's supposed to be C, right? And we have already identified the equation of f, right? F of x is equals to x squared plus bx minus what? Minus 3, right? Minus 3. And we have proven in the previous question that b is equals to 2. So f of x is equals to x squared plus 2x minus 3, right? And then now, to find the coordinates of C, which is the turning point of f, we're going to say x equals to minus b over 2a is equals to minus 2 over 2 into 1, right? Equals to minus 1. So this is the x value of the turning point, which is minus 1. And then to find the y value, we substitute into f of x, right? Plus 2 into minus 1 minus 3. It will give us minus 4, right? So therefore my C, which is my turning point, is gonna have coordinates of minus 1 and minus 4. So these are the coordinates of C. Now we're done with these coordinates of C. We're going to write down the range 4.4 wants us to write down the range of f. So C, remember, it's minus 1, minus 4. So these are the turning points, right? TP. And to find the range, you say y is greater or equals to this y value of your turning point, which in this case is minus 4. So that's how you're going to write down your range, right? So range is actually the y value, so you're predicting the y value. So if you were to write the turning point here, you're predicting the movement of y value. So this y is equals to minus 4 is the lowest value of y of the graph of f. So it starts from that lowest value of y of minus 4 all the way up. There's no other value that is less than minus 4 in the graph of f. Hence we choose this as our final answer for the range. And then we go to 4.5, where they say determine the equation of the line through C that passes at an angle of 45 degrees with the positive x-axis, right? So what are they saying here? So let me first erase. We are told that I must determine the equation of the line through C that creates an angle of 45 degrees with the x-axis. So what it means is we're having this line that passes through C, right? It goes something like this, something like this. So this line creates a 45 degrees here, and it passes through this point C. So we want to identify the equation of this line. We know that since it's a line, it's going to be y is equals to mx plus c, right? But because it's 45 degrees, you can say tan of 45 degrees equals to the mass, of which tan of 45 degrees equals to 1. So the mass is equals to 1, right? So you have y is equals to x plus c now, right? So for us to find the value of c, we need to substitute point C, because that's where the straight line passes through. Substitute point C of minus 1 and minus 4. We will say where there's y, put minus 4 is equals to where there's x, put minus 1 plus c. Therefore c is equals to, transpose the minus 1 to the other side, we have positive 1, so it's minus 3, right? So the equation of this line is going to be y is equals to x minus 3. So this is the equation of the line that passes through C. And then now that we're done with that, what we're going to do now is in 4.6, is the straight line determined in 4.5 a tangent to f? Explain your answer. So 4.6, is it a tangent? Well, it depends, right? So for it to be a tangent, it must pass through point C only, right? Let's say you have a parabola like this, and then it passes through just at one point, then it is a tangent. But because this line, if you see the way I drew it, it passes through this point of C, and it also passes through the point of D, right? So it just makes it not a tangent, because a tangent passes through a graph at one point. So the answer for 4.6, you say no, it's not a tangent to the graph. Why? Because it passes through point C and D, right? So that is the answer for this question here. And then 4.7, which says that the function of h of x is equals to f of x, it's supposed to be f of x minus, so here it's minus, so f of into m minus x, right? And plus q has only one x-intercept at x is equals to 0. So this is equals to 0, x equals to 0. So here it's f of m minus x plus q. Determine the values of m and q. Okay, cool. So we're having this function of h of x, right? And you're told that it has only one x-intercept at x is equals to 0, right? So remember that our f of x is actually equals to x plus 1 squared minus 4, right? Remember, why am I saying that? Remember this equation here, and we knew that our c value, it's minus 1 and minus 4, right? So this would be the equation, right? This would be the equation of f of x, right? So now we can substitute, we can say h of x is equals to, so in f of x we're just going to put m minus x, so we're just going to say m minus x plus 1 squared minus 4. So I'm just literally putting this inside, but I'm putting this this m minus x here at x, hence we're having m minus x and then there's 1, right? So the same goes with this minus 4. I just placed it here, which is the same as this one here, right? Cool. So this is what I'm having. So what this means is this, so this would be plus q, right? So if I were to write it nicely, h of x is equals to into m minus x plus 1 squared minus 4 plus q, right? So to find the value of q, you can say minus 4 plus q is equals to 0, whereby q is equals to 4. So that is the solution for this one. And then to find this m here, you will say m minus x plus 1 is equals to 0, but you're told that the x-intercept is actually equals to 0, right? But x is equals to 0, so m minus into 0 plus 1 equals to 0. So therefore m is equals to minus 1. So you have found your value of q and your value of m for this question here. F of x is equals to k to the power of x, where k is supposed to be greater than 0. The point of 416 lies on the graph of f. So we are given this graph here, and the first question of 5.1 is to determine the value of k, right? So to determine this value of k here, we have f of x being equals to k to the power of x, right? So we're going to use this point here, which is point of 4 and 16, and this is x, this is y, so we're going to substitute in this equation here. So where there's y, you put 16 equals to k to the power of 4, right? And then you can just multiply with 1 over 4 both sides, 1 over 4 both sides, and you should get k being equals to 2. Okay, so we are done with this question here. Let's do 5.2, which says that graph G is obtained by reflecting graph F about the line y is equals to x. Determine the equation of G in the form of y is equals to. So this graph of G that the question talks about is reflected about this line of y is equals to x. Y is equals to x. So what's going to happen is this, the reflection is going to cause this coordinate here of 0 and 1 is going to be 1 and 0 here, right? And this coordinate here of 4 and 16 is going to be 16 and 14. So let me first draw the graph. So it's gonna look like this. So the graph of g is gonna look like this, and then here is going to be 16 and 4, right? So to write down the equation of this graph of g of x, we're gonna use the f of x being equals to k to the power of x, right? And we found k to be equals to 2 in the previous question. So f of x is equals to 2 to the power of x, which is y is equals to 2 to the power of x, right? So we're just gonna, where there's x we put y, and where there's y we put x, right? So we're just gonna say x equals to 2 to the power of y, and then we use our logs by saying y is equals to log of base 2x. So this is going to be the equation of this g of x, which is going to be y is equals to log base 2x, right? So that's how we solve this problem here. So 5.3, we are asked to sketch the graph of g, indicating on your graph the coordinates of 2 points on the graph. So the graph is exactly the one that I just did, which is this one here, and it has this point here of 1 and 0, and this point here of 16 and 4. So this is the graph of g of x. And then 5.4, use your graph to determine the values of x, for which 5.4.1, when you multiply the y value of f of x with the y value of g of x, you're getting a solution which is greater than 0, which I wanted to say positive solution, right? So we want to look at a situation when that happens. So where does that happen? You go back to your graph. So this is f of x, right? F of x, and this is g of x, right? So where in this graph do you multiply the y value with another y value and getting a greater than 0 solution, right? So what we need to first look is, because for you to get a greater than 0 solution, you have to, when you multiply a positive with a positive, you're going to get a positive, right? Or when you multiply a negative with a negative, you're going to get a positive, right? So you want to check where both y values are positive, or where both y values are negative, right? So unfortunately in this case, there is no situation like this one where both y values are negative, right? Why am I saying that? It's because here the graph of f doesn't have negative y values, right? So only the graph of g has negative y values. So this situation is out. So we're going to look at a situation where we have both positive y values. When you multiply them together, you're going to get a positive solution. So that applies because here it's positive, 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 right? Going up as positive. So everything is positive here. Positive. So what am I saying? I'm saying y values are positive here. Y values are positive, right? Because it's the y-axis, the positive y-axis. So even here, so here there are negative y values, negative, 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 negative y values. But here they start to be positive y values, positive, 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 positive y values, right? So we're going to start where y values start to be positive. So in this case, they start from this side going up, right? But we don't really care much about this portion of the graph because there is no g of x in this side. So we're going to start where g of x starts with positive y values, which is this point here. So this point here is where g of x has positive y values, and you start to So at this point here also, so even though here we have positive y values for the f of x, but there's no positive y value for g of x, it's only negative. So this positive multiplied by this negative here gives us a negative solution, so we don't want that. So but here we're having positive solutions of y, and when you multiply them with this positive solution of y, they give us a positive solution of y. You get what I mean? When you multiply these y values I'm talking about with these y values, you get a positive solution of y. Hope I rephrased that correctly. So that is what we're looking for. So where does it start? As I said, indicated with this line, dotted line, it starts at x equals to 1. How do I know that? Here, just here, we have a coordinate of 1 and 0, right? So that's where this starts. So you can just conclude your answer by just saying when x is greater than 1, right? Why am I using greater not equals to? Is because it's strictly because of this this inequality sign. It's just saying greater. So if it had an equals to, then I was going to put an equals to, but because it just said greater, I'm just going to use greater. So when x is greater than 1, of which we can see from this from these lines that I just did, this, right? When x is greater than 1, we have y value that is positive here, we also have y value that is positive here. So we're having both positive y values giving us a positive solution of y. So this is going to be your final answer for this question. Okay, so 5.4.2 says that when you have g of x being less than or equals to minus 1, so what is the solution of x when that happens, right? So as I said, when you see g of x, they're talking of y values, right? So you look at the y values, the behavior of y values, where in the graph where you have your y values being less or equals to negative 1, right? So because we're looking at this g of x, right, and the negative y values of this g of x starts here, right? So it's negative, 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 going down, right? But we know very well that this graph doesn't touch this this y-axis, right? Why? Because it's an inverse, and there's a, remember that we're having an exponential equation. Normal exponential equation is ab to the power of x plus q, right? Which this is an asymptote, right? For this one, it's a horizontal asymptote for this f of x. So, but because we are having y is equals to log of x, right, like this, so meaning that this same horizontal asymptote becomes vertical in this case, so it moves like this, it goes down like this. So this graph of g won't touch this asymptote, right? So this asymptote is at y is equals to 0, right? Yes, it's at y is equals to, sorry, it's at x is equals to 0. So x is equals to 0 at this point, right? Yes, because this is a y-axis, so x is 0 at the y-axis, right? So it's not really touching the y-axis, right? So how we can do this, we will say, we can easily say g of x less than or equals to minus 1, and just put the equation of the g of x, which is log base 2x less than or equals to minus 1, right? And then you just find the value of x. So you can do that by saying, so this 2 here is going to be the power, so it's going to be x is equals to, it's less than or equals to 2 to the power of minus 1, which is x being less than or equals to 1 over 2, right? So this is the first solution that you have here of when g of x is less than or equals to minus 1. but we also know that it won't touch the y-intercept, right, where x is equals to 0 I indicated. So your final answer can simply be this solution here of but you have to write it as when x lies between your 0, right, removing this equal sign because your graph will not touch the 0, and equals to 1 over 2, like that, right? So this is going to be your solution for this problem, where the graph will not touch the y-axis when x is equals to 0, and you will get your negative 1 solution at x is equals to 1 over 2. So this is the solution for this problem here. When x lies between 0 and half, you will get a solution of y which is less than 1. Okay, so now we're going to do 5.5, which says that if h of x is equals to f of minus x, calculate the value of x for which f of x minus h of x is equals to 15 over 4, right? So let's first find h of x. So we know f of x is equals to k to the power of x, of which we found k to be equals to 2 in the previous questions. So f of x is equal to 2 to the power of k, right? So to find h of x, we can say h of x is equals to, because it's equals to f of negative x, so where we see, sorry, just to indicate here that this is x and not k. So where we see f x, we're going to put minus x, right? So it's going to be equals to 2 to the power of minus x. So this is the equation of h of x. So we have the equation of h of x, we have the equation of f of x. So we're going to say f of x minus h of x is equals to 15 over 4, right? So f of x is equals to 2 to the power of x minus h of x is equals to 2 to the power of minus x, right, equals to 15 over 4. So what you're going to do here is we want to calculate the value of x, right, for which this happens. For us to do that, we need to we can use the value of k. We will say 2 to the power of x minus 1 over 2 to the power of x is equals to 15 over 4. So to solve for this value of x, we can say let 2 to the power of x be equals to k, right? So when we see 2 to the power of x, we're going to put k, so it's going to be k minus 1 over k is equals to 15 over 4. And then we can multiply by k all sides to remove this k at the bottom. So multiply by k, multiply by k, multiply by k. And then we will have k squared minus 1 is equals to 15 over 4k. Right, so you transpose this k to the other side, we'll have k squared minus 15 over 4k minus 1 equals to 0, right? So what we will have is this. So we'll have k squared minus 15 over 4k minus 1 equals to 0, right? And we can multiply, remove the denominator of 4 by multiplying it, right? So you're going to multiply by 4, multiply by 4, multiply by 4, multiply by 4, and we'll have 4k squared minus 15k minus 4 equals to 0. And then we factorize this expression here equals to 0. So it's going to be 4k and k here, and we can put 4 here. When you multiply these 4 and 4, sorry, you're going to get 16, but we know that another factor of 1 multiplied by k is going to give us 15, right? So we can say negative here and positive there, right? So now we have 4k plus 1 being equals to 0, or k minus 4 equals to 0. So we transpose the 1 to the other side. We have 4k is equals to minus 1, k is equals to 4, and divide by 4 both sides. So you have k being equals to minus 1 over 4. So yeah, remember that remember we said 2 to the power of x equals to k. So we can replace that now by saying 2 to the power of x equals to minus 1 over 4. 2 to the power of x equals to 4, right? So here we can change this into 2 to the power of 2, right? And we can write 2 to the power of x being equals to minus 2 to the power of minus 2, right? So the reason why this will not have a solution of x is because of this negative here. The bases are not the same because of that negative. So hence this one has no solution. But we're going to continue from here. So we're having 2 to the power of x equals to 4, which you will have 2 to the power of x equals to 2 to the power of 2. So therefore x is equals to 2. So that is the solution of x for this problem here. X is equals to 2. Looking at question 6, 6.1 says that two friends, Kuda and Tabo, each want to invest 5,000 Rand for a period of 4 years. Kuda invests his money into an account that pays simple interest at 8.3% per annum. At the end of the 4 years, he will receive a bonus of exactly 4% of the accumulated amount. Tabo invests his money into an account that pays an interest rate of 8.1% per annum compounded monthly. So whose investment will yield a better return at the end of 4 years? Justify your answer with appropriate calculations. So this is it's pretty straightforward. Let me just first indicate the information for each. So we're having Kuda, and the information that we have is this. Kuda also invests 5,000 Rand at a simple interest, right? So at a simple interest rate of 8.3% per annum, right? So what we have is that the investment is equals to 5,000 Rand, and the interest rate is 8.3% per annum using simple interest. And there's another thing that we are told is that bonus is 4% of the accumulated amount. So if we represent this into our timeline, we will have T0 there and T4, which is the period of 4 years, and the investment happens here of 5,000, right? And we know very well that the interest rate from T0 to T4 is equals to 8.3% per annum, right? So the accumulated that we're going to find here, there's a bonus of 4% of the accumulated. So to really calculate this, because the question says that we need to know which investment yields better return, right? So what we're going to do is this. We are going to use, because this is a simple interest, so you will say A is equals to P into 1 plus I multiplied by N, right? We want the accumulated, so the present value is the 5,000 that was invested at T0, so it's 5,000 into 1 plus the interest rate of 8.3. So you will divide that 8.3 over 100, you will get 0.083, right? And then multiply by 4 years, right? So the answer that you're supposed to get is 6660, right? So this is the accumulated amount, right? But remember that there's a bonus of 4%. So what is 4% of this amount here? What you can do is you can say 4% of the amount is equals to 4% multiplied by the amount of 6660, right? So this amount here, you will add it with the original amount that you got to get the actual amount, because this is just the bonus, right? So the actual amount is equals to 6660 plus the interest of 4%, 6660. So the actual amount, so you're gonna punch in your calculator this entire value here of 6660 plus 4% of 6660, and you're supposed to get 6926.4. so this is the amount that Gura is going to get towards his investment. So now let's try to look for the situation of Thabo, right? So we know that Thabo invests 5,002 at a period of 4 years, and if we check here, Thabo uses an interest rate of 8.1% compounded monthly. So for Thabo, let me just do this. So for Thabo, he also invests an amount of 5,000 rand at an interest rate of 8.1% compounded monthly for a period of 4 years, right? N is equals to 4 years. So we have his timeline looking like this. So this is T0, T4. The interest rates from here to here is 8.1% compounded monthly, and we know that the investment of 5,000 was made, and yeah, for a period of 4 years. So to calculate the amount of Thabo, so you're going to say A is equals to P into 1 plus I to the power of N, because it's compounded, hence we're going to use compound formula. So it's going to be 5,000 into 1 plus the interest rate of 8.1%. You can convert that, so you can say 8.1% divided by 100 and get the proper number of 0.081. Then you divide by 12 because it's compounded monthly to the power of 12 times the 4 years. So the answer that you need to get is 6,905.7, right? So looking at these amounts, for Thabo, we're having an amount which is equals to 6,905.7, and then for Kuda we have an amount which is equals to 6,926.4. So definitely it's easy to tell which investment yields a better return here. We're gonna look at the one that has the higher amount, right? This is 6,905, this is 6,926. So definitely Kuda yields better return. So Kuda's investment yields better return. Fine, done with this question. So now we're going to do 6.2. 6.2, which says that 9 years ago a bank granted Mandy a loan of 526,000. So this loan was to be repaid over a period of 20 years at an interest rate of 10% compounded monthly. So Mandy's monthly repayments commenced exactly 1 month after the granting of the loan, right? So 6.2.1, Mandy decides to make monthly payments of 6,000 instead of the required 5,066 rand 0.36, right? How many payments will she make to settle the loan? So this is pretty straightforward. I'm just going to write the information that we have here. So the amount of the loan is 525,000, and the amount that Mandy is going to pay is 6,000 monthly, and interest rate is 10%, right? Let me just check. Yes, it's 10% for a period of 20 years. So it's going to be 10% compounded monthly, and for a period of 20 years. So our period is 20 years, but the question wants us to identify the number of payments that are supposed to be made, right? So please ignore this portion here for now. This period of payment of this loan of 20 years, right? Please ignore it for now. In this question, we just want to find the number of payments. Remember that I just want to remind you that N in annuities doesn't mean number of years, it means number of payments. Please note that when you're dealing with annuities, N stands for number of payments. When you're dealing with simple interest or compound interest formula rather, N stands for number of years, right, or period, right? So because we want to identify the number of payments, and we know this is a loan, so we're going to use the formula of the present value annuity, which is x into 1 minus into 1 plus I to the power of minus n divided by I, right? So the loan that is taken here is 525,000 is equals to, so payments would be 6,000 rand every month, so it's going to be 1 minus into 1 plus the interest rate of 10%, so 0.1 divided by 12 because it's compounded monthly, minus n, and then we divide by 0.1 over 12, right? So I'm just going to calculate the value of n, which is the number of payments. We want to know how many payments will be made for this 6,000 rand. So we're just going to cross multiply here. We'll have 525,000 multiplied by 0.1 over 12 is equals to 6,000 rand into 1 minus into 1 plus 0.1 over 12 to the power of minus n, right? And we divide by 6,000 both sides, and we'll have 525,000 multiplied by 0.1 over 12 divided by 6,000 is equals to 1 minus into 1 plus 0.1. If you check, I'm not punching anything from the calculator as yet, because that would be premature punching of the calculator. You know, you'll run off and then your answers won't be accurate towards the end. So you need to just do as I do here, by just writing the entire thing, and you'll punch everything towards the end, right? So we're going to transpose the one to the other side. We have minus 1 is equals to minus into 1 plus 0.1 over 12 to the power of minus n, and then now you can start punching this into your calculator, this whole expression here. Just punch it in the calculator and tell me what you're finding. So you're gonna get minus 13 over 48. So let me write it properly. So it's minus 13 over 48 is equals to minus into 1 plus 0.1 over 12 to the power of negative n. So because it's negative, so the negative will go away. You will remain with your 13 over 48 is equals to 1 plus 0.1 over 12 to the power of minus n. So because we're looking for minus n, so we're looking for n rather, so we have minus n is equals to the log. The base is 1 plus 0.1 over 12 and 13 over 48. So now you're going to punch this in your calculator. You're going to punch this here and tell me what you find. So it's going to be negative n is equals to you should get a negative 157.40. so the negative goes away. N is equals to 157.40, so just round up. N is equals to 158. So this is the answer for this problem here. So these are the number of payments that Mandy is going to make for the loan. Right, so we are done for this question here. We are done with 6.2.1. now we go to 6.2.2. right? So yeah, after making monthly payments of 6,000 rand for 9 years, Mandy required money to fund her daughter's university fees. She approaches the bank for another loan. Instead, the bank advises Mandy that the extra amount repaid every month could be regarded as an investment, and that she should withdraw this full amount to fund her daughter's studies. Calculate the maximum amount that Mandy may withdraw from the loan. So remember, Mandy was supposed to pay an amount of 5,066 rand 0.36 for the loan of 525, right? But Mandy paid more than that, so Mandy paid 6,000 rand. So there's a remainder of amount for her from the loan that she can use to actually pay for these fees. So we are mostly interested in the difference between this 6,000 rand and this 5,000 rand, and then we're going to calculate how much money will she have left. So what this means is this: Mandy was required to pay monthly installments of 5,066.36, right? But she decided to pay 6,000 rand, right? So meaning that the difference of these two is actually the amount that she has left, you know, because she's supposed to pay this for the loan of 525, but she ended up paying this. So the difference between these two, 6,000 minus, okay, let me write this properly. So it's x equals to 6,000 minus 5,066.36. So this is the amount that she has left, even though it's not an amount. We're just gonna calculate the amount or the future value annuity. So the difference between these two is just going to give you 933.64, right? So we're gonna use this to calculate the future value annuity of Mandy's payment of the loan. But because we are looking for the future value annuity, we want to know in future if she was paying an extra 933.64, so how much will she have made in future, you see? So hence we're not using the present value here. We just want to know how much will she have made in future. So we're going to use the future value annuity is equals to 1 plus I to the power of n minus 1 divided by I. So in future, Mandy is going to make the following amount, but before we do that, we know x is equals to 933.64. The I is equals to 10% compounded monthly, right? remember that this repayment is made for a period of 9 years, right? So we're just gonna write our 933.64 into 1 plus 10%, 0.1 divided by 12 to the power of 12 multiplied by the 9 years minus 1 divided by 0.1 over 12. So the future value that this extra amount of 933.64 will be 162. Let me just write this properly. So the future value is going to be equals to 162,503.5, right? So this is the future value, the amount that will Mandy will have left, will have remaining, by the way, remaining once she has repaid the loan. So this amount, she can use it to pay for the fees of the student, right? So we are done for this question. Off to the next one. So question 7. Question 7.1, we are asked to find the derivative of f of x using first principle given the f of x of 4 minus 7x, right? So to find f of x plus h, we will substitute the 4 minus 7. Where there's x, we put x plus h, right? And yeah, you can just leave it like this for now. We'll solve it later. Later is now. So we have f prime of x being equals to the limit when h approaches 0 of f of x plus h minus f of x divided by h, right? So the limit when h approaches 0, remember I said f of x plus h is 4 minus 7 into, so it's 4 minus 7 into x plus h, and then let's just put this in brackets minus our f of x is 4 minus 7x, so it's 4 minus 7x like that, divided by h. So the limit when h approaches 0, so it's going to be 4 minus, so the 7 will multiply everything that is inside, so it's 7x minus 7h minus, so this minus will multiply everything that is inside here, so you have minus 4x, sorry, minus 4 plus 7x divided by h. So what's going to happen is like terms will subtract each other, and then we remain with 7h. Is it negative? Negative. So it's the limit, by the way. So it's going to be equals to the limit when h approaches 0. We have what's this? We have 7 minus 7 h over h, right? The h goes away, so we remain with minus 7. So that would be the answer, the derivative of f of x. You always have to check whether your answer is correct by writing your f of x, which is equals to 4 minus 7x, right? And the derivative of this is definitely, it's a 0 at minus 7, so which is equals to minus 7. So you know that your answer is actually correct. Always check, please. So we're done with this limit here. Now we're gonna go to 7.2. We're asked to find the derivative of this. So let me just remove this. So to find the derivative of this, what you can do is we'll change how we write this here. We know it's the root is a square root, rather there's 2 there, so meaning that it will change how we write. So it's going to be y is equals to 4x to the power of 8 plus x to the power of 3 into 1 over 2, right? So this is 3. and then y is equals to 4x to the power of 8 plus 3, plus x to the power of 3 over 2. So now we can find the derivative of y with respect to x. So we're going to drop the 8, let me do this, drop the 8 into 4x to the power of 8 minus 1, close brackets, plus drop the 3 over 2 into x to the power of 3 over 2 minus 1, and the d of y over d of x is equals to 8 times 4, which should give us 32. It's going to be x to the power of 7 and plus the 3, right? And you subtract at the top, you should get 1 over 2, so it's going to be x to the power of 1 over 2 over 2, right? So the final answer would be d of y, by the way, d of y over d of x is equals to 32 x to the power of 7 plus 3 over 2 x to the power of 1 over 2. So this is the final answer, but if you don't want to write it like this, you can just say dy over dx equals to 32x to the power of 7 plus 3. So you put it on square root because this is a 2 at the bottom, divided by not the entire thing, but just this one divided by 2, right? So this is the final answer of this problem here. Let's do 7.3. So 7.3, we are given y is equals to ax squared plus a, and we're asked to find the derivative with respect to x, dy with respect to x. So you're deriving y with respect to x. So you're having your y is equals to ax squared plus a, and to find dy over dx, so you're deriving this x squared, which would be 2ax plus 0, right, because this is a constant. So dy over dx is equals to 2ax. So this is the final answer for this one here. So now let's do another one. So 7.3.2, we are asked to derive, let me just write the equation. So it's y is equals to ax squared plus a, right? So deriving y with respect to a. So when you derive this a here, it will remain. So it's going to be x squared, and then deriving a, it's going to be plus 1, right? So this would be our final answer for this problem here. So we're just going to go to the last question, this one here, and what we are given and asked to do here. So we are given, so 7.4, the curve of the equation passes through this point of a. Determine the equation of the line perpendicular to the tangent to the curve at a, right? So we're having our equation y is equals to x plus 12 over x, and we are told that it passes through point a of 2 and b. So let's find b since it passes through it. So we're just going to substitute. Where we see x, we put 2. Where we see y, we put b. So this is going to be b is equals to 2 plus 12 over 2 equals to 2 plus 6, which is equals to 8. So b is equals to 8. So this means is our a would be 2 and 8, like that, right? And our equation of y is equals to x plus 12 over x now. So determine the equation of the line perpendicular to the tangent to the curve. So the tangent to the curve, so we have the curve being equals to x plus 12 over x, right? So let's find the derivative of this curve. Why are we finding the derivative of this curve? Is because they're talking of a tangent, and the tangent is perpendicular to this line, so we just want to find the gradient of the tangent first, and then we'll sort out everything. Or we can find by deriving here, we can substitute, right? Substitute these points here. All right, so let's just first derive this. So d of y over d of x, but before we derive, let's take this x at the top, so it's going to be y is equals to x plus 12 x to the power of minus 1. So d of y over d of x is equals to 1 plus, so we drop the 1, so it's going to be 12 into minus 1 x to the power of minus 1 like that. So d of y over d of x is equals to 1 minus 12 x to the power of minus 2 like that. So that is the derivative, right, of this expression here. And what we need to note is that this derivative, the tangent, the x value of the tangent is the point of A actually. So let me just write it nicely. So d of y over d of x is equals to 1 minus 12 x to the power of minus 2. But we need to remember that it passes through this point of 2 and 8. We found b to be 8. So we're just going to substitute this x value of equals to 2 and find the actual gradient of this tangent. 1 minus 12 into 2 like that, minus 2 should get your gradient to be minus 2 if you punch in your calculator. So this is dy over dx, right? So it's the gradient of the tangent, and you're told that this line is perpendicular to the tangent, right? So m of t is equals to minus 2. That you should note. But we are told that m of t is perpendicular. So if it's perpendicular, we multiply the gradients. It must be equals to -1, right? So the gradient of the tangent is minus 2. We don't know the gradient of the line that is perpendicular to the tangent, and then it's equals to -1. So we divide by -2, divide by -2 both sides. So m of the line is equals to 1 over 2, right? So now we know the gradient of this line here, right? Gradient of the line equals to 1 over 2 there. And now, because we are asked to determine the equation of this line, right? So we also know that this line passes through point A, right? So our A being 2 and 8, right? So we have y is equals to mx plus c. So this is the equation of the line. So y of the line is equals to the gradient of 1 over 2x plus c. So substitute these 2 points here of 8 and 2. It's 8 is equals to 1 over 2 into 2 plus c. So this 2 goes away. We have 8 is equals to 1 plus c. 1 goes to the other side. We have c being equals to 8 minus 1. C is equals to 7. So the equation of the line is equals to 1 over 2x plus 7. So this is 7. So yeah, this is the equation of this line here. Done with this question, off to the next. Let's do this question 8. I think it's zoomed properly now. Hope you can see wherever you are. So the statement reads as follows. After flying a short distance, an insect came to rest on a wall. Okay, so this is question 8. The statement reads as follows. After flying a short distance, an insect came to rest on a wall. Thereafter, the insect started crawling on the wall. the path that the insect crawled can be described by this equation, where h is measured in centimeters. It's the height above the floor, and t is time, which is measured in minutes since the insect started crawling. So 8.1 says that at what height above the floor did the insect start crawling? So it started crawling. So you think of it in terms of a Cartesian plane, where you have your height here and you have your time there, right? When you talk about it starting to crawl, it's where t is equals to 0, right? It started crawling at a certain height, right? But you don't know that height, so but we know that t is equals to 0 at that height, at that specific height, because the movement can be, if you look at this equation, it is actually cubic, so it can be in cubic form like this, right? So just to answer this question, it started crawling at t is equals to 0, so meaning you're gonna substitute h of 0 here in this equation that you're given. Just gonna put 0 where there's t, so it's 0 minus 6 and minus 2 into 0 squared plus 3 into 0 minus 6, right? I hope everything is clear, but to write it nicely, I'm going to do it here. So t equals to 0, which is h of 0 is equals to 0 minus 6 and minus 2 into 0 squared plus 3 into 0 minus 6. So this will be 0, this will be 0 and 0, so it's going to be h of 0 is equals to minus 6 and minus 6, which will give you 32. So this is 32 centimeters. So this is basically your y-intercept, right, when x is 0. It's just that, you know, when you read these things in real life, you know, some students ask, but where do we use maths in real life? So this is the one of the examples of real life situations for maths. So yes, we found our h to be 32 centimeters. Now let's do 8.2. How many times did the insect reach the floor? You see, so if we don't picture how we've been calculating things over the years or over months or whatever, then we won't be able to answer this question. It asking us how many times did it reach the floor. Picture the floor as a Cartesian plane again. As I said, this is h, this is t, right? And this thing touched the floor. So whenever it touched the floor, so think of it as, oh, these are x intercepts, right? When y is 0, right? When the height is 0, because the floor, there's no height. You are standing on the floor, there's no height, so it's 0, you know. So when it touched the floor, the height was 0, right? So how many times did the insect touch the floor, reach the floor? So we want to identify how many x intercepts, which in this case, those x intercepts are your times t, right? So please note that. So we just want to know how many times it touched the floor. So we're just going to use our equation of h of t is equals to t minus 6 and minus 2t squared plus 3t minus 6. Actually, let me write it in another page so that you can see clearly. So h of t is equals to, let me just see. So it's t minus 6 and what? Minus 2t squared plus 3t minus 6. Minus 2t squared plus 3t minus 6. Okay, so we want to know how many times it touched the floor. And when it touched the floor, we know very well that h of t was equal to 0. The height was 0, right? So we're going to say t minus 6 and minus 2t squared plus 3t minus 6 equals to 0. T is equals to 6, that's the first one, or minus 2t squared plus 3t minus 6 equals to 0, right? And then you can find t for this problem here, which I did that previously earlier on, and I found that you can use your quadratic formula here, or you can factorize if it's possible to factorize. So I found that this was actually no solution, because it was giving you a negative square root. So in the square root you're getting a negative number, right, which is just an error. So the graph, the insect touched the floor once at t is equals to 6. So we can just confirm, because they said how many times does it touch the floor. It touches the floor, or touches the floor once, right, at t is equals to 6. So that is your answer, because if you just write this answer here, you're just going to get 1 mark and you won't get full marks, you see. So you need to answer the question. Yes, you answer the question in calculation form, and also conclude with just word form. So we are done with this question. So now we're going to do the last part of the question, which is 8.3. Said determine the maximum height that the insect reached above the floor. Maximum height that the insect reached above the floor. I said initially, if you remember clearly, that this equation is actually a cubic function. If you check, the first part is a quadratic, the second part is linear. So when you multiply both, you get a quadratic, a cubic function. So want to determine the maximum height that the insect reached above the floor, sorry. The maximum height that the insect reached above the floor. So we know that our h of x is equals to t minus 6 and minus 2 t squared plus 3t minus 6, right? Let me just first find the product, and then I'll explain everything else. So h of t is equals to, so I'm going to multiply through this t in each and every value here, and also 6 in each and every value there. We all know how to find the product. If you don't know, please ask me in the comment section below, but I'm just doing it as we speak. So it's going to be this t multiplied by this minus 2t squared, which will get minus 2t squared, t cubed, sorry, minus 2t cubed, and then this t multiplied by 3t, so it's going to be plus 3t squared, and then t multiplied by minus 6, so it's going to be minus 6t, and then minus 6 minus multiplied by minus 2t squared is going to be plus 12t squared, and then this same minus 6 multiplied by 3t is going to be minus 18t, and then minus 6 times minus 6 is plus 36. Collect like terms, you have h of t being equals to minus 2t cubed, and then you add these two here, you get plus 15t squared, and then these ones here you have minus 24t plus 36. So this is your h of t. Once you identify the maximum height above the floor, right? So yes, I guess the question says that the maximum height reached by the insect above the floor. As I said, for you to understand what's happening, think of it in a graph format. In this case, this is a cubic function, and this cubic function is an a value which is less than 0, right? So which means if it's less than 0, if you were to just write the movement of this, it's going to be, it's going to decrease, increase, decrease, right? I'm sorry with the background noise, it's beyond my control. So it's going to decrease, increase, decrease. This happens when your a value is less than 0, but when your a value is greater than 0, your cubic function increases, decreases, increases. I hope you know this. I'm just doing a mini small revision with you guys. So that is that. So in this case, our a value is less than 0, meaning that our function is decreasing, increasing, decreasing, right? You'll see why I just drew that. So now what we want to do is this: we're having our cubic function there and want to find the maximum height. So the first thing we need to do is we need to derive this. So we're having h of t is equals to minus 2t cubed plus 15t. Actually, let me write with a black pen. I think it's clearer. H of t is equals to minus 2t cubed plus 15t squared minus 24t plus 36. So to derive this h of t, the derivative is minus 6t squared plus 30t minus 24, right? Then we equate this to 0, and then we get minus 6t squared plus 30t minus 24 equals to 0. Divide by minus 6 all sides. We're going to get t squared minus 5t plus 4 equals to 0. Factorize this t and t, 4 and 1, negative and negative equals to 0. T is equals to 1 or t is equals to 4. So we have t is equals to 1 and t is equals to 4. So I'm not gonna present a Cartesian plane, but in just general sense, t is equals to 1 and t is equals to 4. T is equals to 1 would be somewhere here. T is equals to 4, sorry, would be somewhere here, and then t is equals to 1 would be somewhere here. T is equals to 1 would be somewhere here, right? So you can see now that the point of maximum is actually here, right? And not t is equals to 1. So we can only consider t is equals to 4 because this is the point of maximum for this function here. So what you're gonna do is this: this is not equals to this, but it's equals to that. So when I say t is equals to 4, now I want to identify the height at t is equals to 4. So we use our equation. H of t is equals to what's the h of t is equals to minus 2t cubed, right? And plus 3t, no, sorry, not plus 3, plus 15 plus 15t squared minus 24t plus 36. So let's substitute when t is equals to 4 because that's when this insect reaches maximum. So it's minus 2 into 4 to the power of 3 plus 15 into 4 to the power of 2 minus 24 into 4 and then plus 36. So the maximum height that you need to get, just punch this into your calculator, you should get 52 centimeters. Remember, the height is measured in centimeters, so height at t is equals to 4 is 52 centimeters, right? So yeah, we are done with this question here. Okay, so we are given a function of f of x being equals to 3x to the power of 3, and 9.1 we are asked to find or solve for f of x is equals to f of prime of x. So f of x is given as 3x cubed, and f of prime of x is going to be 9x squared. So if you equate the two, equals to f of prime of x, and then if 3x cubed is equals to 9x squared. You transpose this to the other side, you have 3x cubed minus 9x squared equals to 0. Factorize 3x squared into x minus 3 equals to 0. So it's 3x squared equals to 0, therefore x is equals to 0, the first solution of x, or x is equals to 3, so this is the second solution of x, right? So we are done with solving this problem here. And then 9.2, we are given graphs of f prime, f prime prime. All passes through the point of origin of 0 and 0. So 9.2, for which of the graphs will have 0, 0 as their stationary point? The first derivative, f prime, so let me write it properly. So f prime will have a stationary point, and f
graph of f will have stationary points. So 9.2, explain the difference, if any, in the stationary points referred to. So f prime will give you your turning points. So it give you your turning points of the function. So let me write turning points, right? And then our graph of f will give you, I can give you your x-intercepts when the function of f is having the turning point at that intercept, right? So, or it can give you the point of inflection. So what do I mean by it will give you the x-intercept? You can have a situation where your cubic looks something like this, and then it looks like this, right? So this point here is the turning point of f, right? Of function f of x. It's a turning point. It's also an x-intercept. And this region here is 0 and 0, so it's stationary, right? So hence I'm including this statement of saying it will give you the x-intercept if at that region it is a turning point, right? And then you have your point of inflection there. So done with this section here. And 9.3, determine the vertical distance between the graph of f and f prime at x equals to 1. So f prime is equals to 9x squared, and f prime prime is equals to 18x, right? So the distance is equals to the difference of these. So it's difference of f prime prime minus f prime, right? So it's 18x minus 9x squared, of which x is equals to 1. So the distance is equals to 18 into 1 minus 9 into 1 squared. So it's equals to 18 minus 9, which is equals to 9. So that is the distance, d. And then (9.4) for which values of x is f of x minus f of prime of x is less than 0. So f of x minus f of prime of x less than 0. What is our f of x? It's 3x cubed minus our f prime of x is equals to 9x squared less than 0. So you're going to factorize 3x squared into x minus 3 less than 0. So your critical values are x being equals to 0 or x being equals to 3. So you're going to write down your timeline and indicate your critical values of 3 and of 0. So these are going to be your critical values, right? And then you're going to test values before the critical value, which before 0 there comes -1, between 0 and 3 there comes 2. So I'm just going to circle the values that you're going to test, and then comes 4 here. So if you substitute, looking at this equation here, if you substitute x equals to -1, this value here, you should get a solution that is negative. So I'm just going to write negative. And then if you substitute x being equals to 2, right, which is this one here, so you should get a solution that is -2, right? And then when you substitute x equals to 4, which is this one here, you should get a positive solution, right, of y. So we are mostly interested in negative solutions because of this inequality sign saying it's less than 0, right? It's not greater, it's less than 0. So your solutions of x can be as follows. You can say x is less than 3, right? I'm talking about these 3. So I'm using the critical value to interpret that when x is less than 3, we're having a negative solution of y, which is exactly what we're looking for. Or you can say x is, I think x less than 3 just highlights even this portion here, right? So I can leave it there, or someone can just say when x lies between 0 and 3 and x is less than 0, right? This also applies, especially if you write them both. They both apply. So yeah, we're done with this question here.
Now we're going to do question 10. The statement reads as follows: the school library is open from Monday to Thursday. Anna and Ben both both studied in the school library one day this week, right? If the chance of studying any day in the week is equally likely, calculate the probability that Anna and Ben had studied on the same day. So the probability, so let's say for example, okay, we have 4 days, right? Monday, Tuesday, Wednesday, Thursday, right? So the probability that they studied once is 1 out of 4, right? Because someone can study on a Monday, someone can study on a Tuesday. So you can study on a Monday and not study and not study and not study here, or not study on a Monday but study on a Tuesday and not study on a Wednesday, just like that. So the probability of one studying once or on the same day rather is this, because the probability of Anna studying once a day, right, on the same day with, because the probability, okay, so the probability of Anna studying once a week is equals to 1 over 4, right? And then the probability of Ben studying once a week is 1 over 4, right? But because we want to identify the probability that they both study on the same day, so this is going to be probability of Anna and Ben studying on the same day. So both of them studying on the same day, which is going to be equals to 4 multiplied by 2 over 4, right? So they study on the same day, both of them. So it's going to be equals to 4 over 16, which is equals to 4 goes once and goes 4 times here. So it's just 1 over 4. So 1 over 4 is the probability of them studying on the same day. So now we want the probability of Anna and Ben studying in consecutive days, right? So we have Monday, Tuesday, Wednesday, Thursday, Monday, Tuesday, Wednesday, Thursday. So consecutive days can happen like this. Consecutive 2 days, by the way. Them studying on a Monday and Tuesday, right? Or they'll study on a Tuesday and Wednesday, or they'll study on Wednesday and Thursday. So there's 3 ways. It's either Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, right? And then because they are both of them, they are in pair, right? So you're just gonna write the probability is equals to 2 over 4 multiplied by the 3 ways in which they can study in consecutive days, divide by 4, so it's going to be equals to 6 over 16, right? So 2 goes how many times here? It goes 3 times, divided by 8. So this would be the answer for this problem here. Now we're going to do question 11. 11.1, we are told that event A and B are independent events, and probability of A is equals to 0.4, probability of B is equals to 0.25. So 11.1.1 represent the information given on the on a Venn diagram. Indicate on the Venn diagram the probabilities associated with each region. So drawing the Venn diagram is going to look like this, right? And we will have A here. Let me just represent with a different color. So this would be A, and then this would be B, right? So the probability of A, if we were to write probability of A, we can't just write probability of A inside the box here, right? Because finding the probability of A and B is equals to 0.4 times 0.25. The intersection is equals to 0.1. So meaning here in the middle, I just don't have space. Let me just write here. So we have the probability of A being equals to 0.4, probability of B being equals to 0.25, and probability of A and B is equals to 0.4 times 0.25, right, which is equal to 0.1. And representing this in our diagram, right, so we're gonna have first probability, and then the second one like that, and then this would be A, this would be B, and then the intersection is 0.1, so meaning here it's 0.1, and the probability of A would be, finding the probability of A and writing it here would be equals to 0.4 minus 0.1, which is 0.3, right? So you're going to write 0.3 here, and then the probability of B in this diagram would be the given 0.25 minus 0.1, right? Which is 0.15. So 0.15, and then we want the probability of not A and not B, right? So how we do that is by saying probability of not A and not B, right? So how we can get this probability is by saying 1 minus the union, right? The union, I mean both A and B. So it's going to be 0.4, which is just the combination of the intersection, but let me just write everything 0.3, which is this one here, plus 0.1, which is this one here, right? And 0.15, right? So you're just gonna add all and subtract from 1, and you should get 0.45. So meaning here it's gonna be 0.45. Then yeah, we're done for this. And then 11.1.2 says that determine the probability of A not B. So you're just gonna say 1 minus probability of not B, right? So what you're gonna do is probability of not B is actually probability of B. So 1 minus probability of B to find the probability of A not B, which is equals to 1 minus probability of B we found to be this one here, right? 0.5, right, excluding the intersection, so it's going to be 0.15, so we'll get 0.85. So the reason why I didn't include the 0.1, or I didn't write the 0.25, because that's the probability of B, is because we want to exclude A, right? Or we just want to consider B only without A, so that we get not B. So yeah, this is the answer for this question here. And then let me erase here. So 11.2 says that Motors Incorporated manufacture cars with 5 different body styles, 4 different interior colors, and 6 different exterior colors as indicated. So these are the 5 body styles, and all of these are the interior colors, and these are the exterior colors, right? So there are 5, and here it's 1, 2, 3, 4, so there are 4. Here it's 1, 2, 3, 4, 5, 6. There's 6 in total. Cool. So the interior color of the car must not be the same as the exterior. So you can't be having blue in the interior and also blue in the exterior. So you need to choose another color. So Motor Incorporated wants to display one of each possible variations on its car in their showroom. Excuse me, the showroom has a floor space of 500 square meter, and each car requires a floor space of 5 square meter. Is this possible? So what we're gonna do here is we're just gonna say we're having 5. Now we're choosing, right? We're just gonna choose each style or each color for just one car, and but we're just gonna do that for all the 5 body styles, or let me just say all the 5 cars, right? So what's gonna happen is this: we will have we have 5 body styles. So if we begin by saying we have 5 body styles and we choose one color here, let's say we choose blue. So we're gonna choose that one color, and then we can't choose blue here now at the exterior color, so we can choose silver, right? And when we choose silver, how many colors do we have left? We have 1, 2, 3, 4, 5. So there's only 5 colors left, right? So that is the first option. And another option would be to choose all 5 body styles. Let me just erase this. Choose the 5 body styles. Now we choose gray, and we choose any color. We can choose silver if we want. And how many would we have left? We would be 5, right? So but it doesn't really matter now, because we have actually all the options now. Since there's no gray in this side, we have all the options to choose from. So we have all 6 options. So here we have 1 color to choose, and here it's just 5 body styles. So it's going to be 5 body styles multiplied by 1 color multiplied by all 6 options, and then
plus into all 5 body styles and the black, right? And so there's no black here, so you have all the options, which are 6. So it's 5 times 1 times 6, right? And then we have all body styles, and now we want red, and we cannot choose this red. So how many options do we have? It's 1, 2, 3, 4, 5. So we have 5 options. So it's going to be 5 body styles times 1 times 5. So just going to add all these, right? So it's going to be this one here, which is 25, plus this, which is 30, plus this, which is 30, plus this, which is 25. So when you add them together, you should get 110, right? So once we have that, we want each car holds 5 square meter, right? And we have 110 multiplied by 5 should give us 550. So this space that is required is 500 square meter, of which our 550 is greater than 500 square meter. So therefore there's not enough space, right? So yeah, that's how we solve this problem here, and we are done.
Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comment section below. Don't forget to subscribe to the channel for more videos.